So today we will discuss mainly about flywheel, right? But in order to have idea about this flywheel, first you should know what is a turning moment diagram, because flywheel is a component which is acting as a reservoir, right? So if you take example of your 4-stroke engine, so you are having 4 different strokes: suction, compression, expansion and exhaust, right? So during all the stroke, energy required is different, right? So what happens is, whenever energy generates during the power stroke, this flywheel is going to act as a reservoir of that energy, right, which is generated. So it will reserve that energy and it will provide whenever it is required, right? So in your this engines, the flywheel is used. Similarly, in your riveting operation or punching press, in all this kind of applications, you need to require sudden what we can say, at a particular point of time higher energy is required, while it is not so during the whole cycle. So in this kind of applications, you need some component which can reserve the energy when it is in excess, and which can provide the energy when it is not in the required amount, right? So before going to this flywheel, first we will see what is turning moment diagrams. So turning moment diagram is actually the torque generated, right, versus the crank angle, right? Here turning moment versus crank angle. So this I have written here for your reference only. This we will see in detail when we will see dynamic analysis of forces, right? Dynamic force analysis. This we will see how it has been arrived, right? So here for now you can just have idea that how this turning moment and crank angle are related. That is why I have put this equation, that turning moment is this Ft into R, where if you further elaborate, it will be F into R in bracket sin theta plus sin 2 theta upon 2 under root n square minus sin square theta. Now what is this theta? This theta is crank angle, right? And this F is piston effort, right? While this R is crank radius, right? And this N is equal to actually L by R, right, where R is crank radius and this L is length of connecting rod. Length of connecting rod. So this is how you are having this relation between your this turning moment and this crank angle, right? So now if we see these different diagrams one by one, so what are this mentioned different diagrams? So this particular diagram is of a single cylinder, double acting engine, right? Single cylinder double acting, or you can say 2-stroke, right? Whatever, right? So you are having a 2-stroke in 0 to 2 pi revolution. You can see here the crank angle is varying from 0 to 2 pi, and in that you are having 2 power stroke. Whenever you are having this higher energy generation, that is during the power stroke. So here you are having this particular doubles acting, or you can say that 2-stroke engine, in which one revolution of crank will give you 2 power stroke, right? So if you see here what is happening, actually when this is the line of mean torque, right? Whatever you are seeing, this particular line, right? This line is line of mean torque. it is actually required at every time. So sometimes what happens, the energy generation is in excess, right, like FGH, so that will be stored right in your flywheel. And whenever you are having this actually energy generation is less, here energy generation is actually this much only, right, this much only, but the required is this also required, right, over here, which is mentioned in negative, this is also required, right. So when you are having a flywheel in your mechanism, what will happen is that flywheel is going to provide this required energy during this particular motion, while here it will store this energy because it is in excess, right. So this is how your flywheel is going to work. So basically flywheel is going to help you in regulating the speed, or you can say regulating the amount of supply of energy as per your requirement, right. So apart from this, I guess the bottom one is not that clear, so I am rubbing this so that you can see this T theta diagram properly, right. So this particular T theta diagram is of single cylinder 4-stroke engine. So as you know, in 4-stroke engine, what you are having is you are having only one power stroke in 2 revolution, right. Here this is your single cylinder 4-stroke engine, right. So here you can see suction, compression, expansion and exhaust. So during expansion you are having the maximum torque generation, so this will be stored in your flywheel, and then whenever it is required during the remaining strokes, as you can see it is in negatives, right. So during that time it is going to be provided, right. So this is how flywheel is going to work in your engine, and this particular T theta diagram is for multi-cylinder engine, right. So in this you can have we can start with here also this is your mean energy, right, or mean torque, you can say this turning moment. So at C you can assume that this particular amount is E, as it is mentioned over here, right. If you go to point D, right, as it is mentioned in this table, if you go to point D, the energy is E plus A1, whatever area is there, right, between this CD. So this is E plus A1 at point D. When you go to point E, what will happen? This A2 will be subtracted from this E plus A1, right, whatever was present at that point D. So it will be E plus A1 minus A2. So it will go on like this up to point C again, right, up to point H, and C will be again the start point of the next cycle. So this is how you can have this summation and subtraction of area as per it is above the mean line or below the mean line. So this is how you will have this turning moment diagrams, right. So once you have idea about this turning moment diagram, then we can go for this flywheel, right. So one second. Is there anything? Okay. Okay, yeah. Sorry. So here in flywheel, as I have told you, it is going to store the energy, right. So before start discussing about the flywheel, you have to have idea about maximum fluctuation of energy, right. So maximum fluctuation of energy will be achieved, right, through this what we can say 1/2 I omega max square minus 1/2 I omega minimum square. So you can achieve this maximum fluctuation of energy with this, right, and you can also have maximum fluctuation in your speed, right, maximum fluctuation of speed, right? We are talking about this flywheel. So here omega max and omega mean is related to your flywheel. This inertia is also related to your flywheel. So this is how you can have maximum fluctuation of energy, then maximum fluctuation of speed, right? Similarly, you can have coefficient of maximum fluctuation of energy, which can be given by this maximum fluctuation of energy divided by work done, right? And similarly, coefficient of fluctuation of speed that is given by this omega max minus omega mean divided by this average or mean of this both the speed, right? Like omega max plus omega mean by 2. So this is how some of the things are required, right? So once you have idea about all this maximum fluctuation of energy, maximum fluctuation of speed, then this coefficient of maximum fluctuation of energy and coefficient of fluctuation of speed, then you can go and find some of the relations between this coefficient of fluctuation of energy and your this inertia and this maximum coefficient of fluctuation of speed. So we will derive that relation for this flywheel.
Sir.
Yes.
So, sir, what is this omega d, sir? In the coefficient of fluctuation of energy?
That is work done.
Okay, sir. Thank
you. Yes. So here we will see how we can come up with that equation, because based on that equation you are having multiple questions in your GATE examination. So let us start first with nomenclature. Your I is moment of inertia of the flywheel, right? Then you can have omega max, omega mean and omega mean, right? Or average, you can say, right? This is related to flywheel again. Then you can have kinetic energy of the flywheel, right, at mean speed. Then E is maximum fluctuation of energy, right? K is coefficient of fluctuation of that speed, coefficient of fluctuation of speed, right? Now, as we have already seen, this is nothing but omega max minus omega minimum divided by omega mean, right? Now if you go for this E, that is maximum fluctuation of energy, then it is 1/2 I omega max square minus 1/2 I omega minimum square, right? So if you further go and simplify this, then what is going to happen is you will have this 1/2 I omega max square minus omega mean square, right? Here you can write it like this: omega max minus omega mean and omega max plus omega mean, right? So once you write it like this, then you can have this omega max plus omega mean by 2 into I into omega max minus omega mean. Now omega max plus omega mean by 2 is nothing but mean or average omega, then I, then again omega max minus omega mean. Now what you are going to do is you are going to multiply it with omega mean, so it is omega square mean into I into omega max minus omega mean and divide by omega mean, because you have multiplied with omega mean and divided by omega mean. So now if you write this equation finally, then you can write it like this: E is equal to I omega square, this is mean omega, into K, because you have defined this term as K, coefficient of fluctuation of speed, right? So this is very important equation, because you will be asked questions based on this equation in GATE, right? So this is how you are having this relation. This E is fluctuation of energy, right? Maximum fluctuation of energy. I is the moment of inertia of flywheel. It is generally given with mk square. M is mass of flywheel, mass of the flywheel. K is radius of gyration. Of flywheel, right? Omega mean you know, K you know. So these are some of the important things you have to know, right? So this is how this equation is derived for relation between maximum fluctuation of energy, inertia of flywheel, and this inertia of flywheel, then mean speed of flywheel and coefficient of fluctuation of energy. Now we will see some numerical also from Ratan it is, right? So let us see this, what this numerical is about. So let us see: a double acting steam engine develops 56 kilowatt of power at 210 rpm. The maximum and minimum speed do not vary more than 1% of the mean speed, and the excess energy is 30% of the indicated work per stroke. Now determine the mass of the flywheel if the radius of gyration of the flywheel is 500 mm. So first if you see what is provided here is work done per second, right? Work done per second is given as 56,000 volt, right? Because power is mentioned as 56 kilowatt, right? So this you can also write in terms of Newton meter, right? 56,000 Newton meter, right? And here number of working strokes will be number of working strokes equal to 2 into 210, because it is double acting. So that is why this number of strokes will be 420, right? Now you are having number of working stroke per second, sorry, it is per minute, right? It is actually rpm, so here it is per minute. So if you divide it by 60, then it will be per second. So in short, you have this work done per second and this number of stroke per second. So from this you can derive work done per stroke. So work done per stroke will be 56,000 divided by 420 by 60. So it will give you 8000 Newton meter. So this is the work done per stroke. Now the excess energy, here it is mentioned excess energy is 30% of the indicated work per stroke. So it means your E, right, fluctuation, maximum fluctuation is 30% of this work done per stroke. So it means it is 8000. Yes
सर इंस्टेड ऑफ टेकिंग एक्सेस एनर्जी, सर एक्सेस एनर्जी का मतलब तो वो हुआ ना मीन से कितना ऊपर है.
yes
पर सर वो जो ई होता है वो तो फ्लक्चुएशन होता है ना, ओमेगा मैक्स माइनस ओमेगा मिन जो स्क्वायर करके जो होता है, तो ई
yes
होगा ये.
yes you are correct, but whatever here provided data, as per that we have to go with this only, that whatever fluctuation is there, that is whatever excess energy is required, right? Otherwise you are correct, if the data is provided like that, the total fluctuation graph is provided, like you are having peaks also, and whatever the lowest amount is there, in that case you can go by that. But here from the whatever problem is given, so for now we have to take this fluctuation of energy as per the data given, that 30% of this work done per stroke. So for now your this fluctuation of energy should be taken as 2400 Newton meter. Is it okay?
Okay sir, thank you sir.
Okay. So now K is fluctuation of energy, right? So here what is given about this is maximum and minimum speeds do not vary more than 1%, right? So it means from mean speed it can go beyond 1% and also below 1%. So total fluctuation will be 2%, right? So this K is given as 0.02, right? So now from this data I guess you will be able to calculate this whatever is asked, like what is asked you have to calculate the mass. So if you write E is equal to I omega square K, this is mean always actually. So I is written as mk square, as I have told you, mk square omega square, right, into K. This K and this K is different actually. This is coefficient of fluctuation of speed, while this is small k, that is radius of gyration.
सर
Yes
सर एक चीज पूछो सर, हमारे जो गेट का एनपीटीएल का पोर्टल है गेट के लिए,
yes
सर उस पे ये वीडियोस कब तक आएंगी सर?
that as soon as possible it will be posted.
सर जो सेशंस हुए हैं सर उन पे भी क्लिक कर रहे हैं तो वो खुल नहीं रहे, तो कब तक आएंगे, कब तक हमें अवेलेबल हो सकती है, ये चीज बता सकते हो आप?
Actually we are working on that also, so those video will be made you available as soon as possible. Okay.
Okay sir.
Okay, thank you. So
Thank you, sir.
right now you are having all the data with you, so can anyone calculate and tell me what is the answer of this? Please have your scientific calculator with you so that it will be easier for you to calculate. Right, so this K is 0.02 and this K is 0.5, right, radius of gyration. So please calculate and tell me. You can any one of you can unmute and answer what mass you are getting. E is 2400, right? Omega mean is 2 pi n by 60.
I want to ask a question.
Sorry?
Sir, what is the meaning of double acting steam engine mean?
Double acting steam engine means, see, whenever you are having this piston cylinder arrangement, right, then you are having this what we can say, working stroke at only one side, right, generally. So instead of that, if you are having on both the side working stroke, then it is known as double acting. Got it?
Okay.
Okay.
Yes, sir.
Okay. So now can anyone tell me what is
Sir,
the mass you are
sir,
getting?
sir, but E is the energy per stroke, sir. So how we can equate it to I omega mean square K?
E is fluctuation. Here work
In
done per stroke we have calculated.
Sir,
And
E is
relation
fluctuation.
is given here in the problem statement. How excess energy is related to work done per stroke, that is mentioned in your problem statement.
ओके सर. सो सर मतलब इसका मतलब ये नहीं है कि जो एक्सेस एनर्जी है वो पर स्ट्रोक में है.
नहीं, no.
ओके सर.
Actually, yeah, it is not like that. So
The mass is 992.53.
correct. So your mass will be almost around 992 kg. Correct. So let us go to the next one. Right. So next,
hello.
yes.
Sir, can you explain this when we have to take a coefficient of fluctuation of speed is about mean there is about mean position, so we have taken 2%. When we have to take 1%.
See, if here they have provided you 0.5% on both the side, then you have to go for 1% because you have to multiply it by 2. Because it can go on both the side. Now you are having omega mean, right? So it can go towards omega max as well as omega mean, right? So suppose you take example 10, right? Then 1% of this 10 means 10.1 and 1% less means 9.9, right? So the total fluctuation is 2%, right? So that is why I have taken 2%, right? So if you go with this all detail and put in your that equation of k which we have derived, right? What is the equation of k we have discussed? Omega max minus omega mean upon omega max plus omega, right? Like omega max minus omega minimum divided by mean, right? Mean is 10, so you will get this 0.02, right? 0.2 divided by 10 will give you 0.02. Are you getting what I am trying to say?
Yes, sir.
Clear?
Yes, sir.
सर फॉर अ मोमेंट प्लीज इस वाले क्वेश्चन को फुल स्क्रीन कर दीजिए.
Sir, I have solved a question where it is written that about mean position, but in that question answer is given they have taken the coefficient of fluctuation of the speed as a 1 value. That is 0.01.
I guess there may be some mistake, or you should again read the problem statement maybe, right?
Yes, sir. Sir, I have a problem with me. Can I read it once? If you allow.
Sorry?
I have a problem with me right now. So, sir, can I have read this problem?
You want to read this problem?
No, not this problem. The problem which I have got stuck. That problem.
I guess what you can do is either you can keep it at the end, or you can email me, or if you are there till end in this session we can discuss. Okay,
Sir. Because sir, it is a gate problem.
okay. So we are also going to see gate problems, so maybe your question what you want to ask may be solved during our session only. Is it okay?
Okay, sir.
Okay. So
Sir, in exam, their small k value will be given or not?
sorry, which value?
Sir,
So the small k value,
Small k value is given. If other data is given, then small k value you need to find, right? Small k is nothing but radius of gyration of the flywheel. Okay.
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 sir, will you please explain once again the upper solution of this question?
Sorry.
Work done per second, number of working stroke.
So work done per second is given here, right? Power is nothing but work done per second, 56,000, watt means whatever is there, that is work done per second, 56,000, right? Now if you
Yes.
go for power is what, rate of work done, right? Yes or no?
Yes.
Then number of working strokes per second you have to calculate, while what we have seen is as it is double acting, the number of strokes will be double than the revolution whatever is given, because in one revolution you will get 2 stroke, as I have mentioned here, right here. So in one revolution 2 stroke means total 420 strokes will be there per minute. You need to convert it into second. So when you convert it into second, then it is 420 by 60. So this is stroke per second. So now work done per second divided by stroke per second will give you work done per stroke. Are you getting?
Yes.
Hello. Okay. Is it okay? Hello.
Yes. Yes, sir. Yes.
Okay.
Sir,
Yes.
what is the value of mean speed here?
Sorry.
Mean speed, omega mean.
Omega mean will be from this what we can say, this RPM is given, so from that omega mean is 2 pi n by 60, where n is 210. This omega
Okay,
mean will be 2 pi into 210 by 60, 2 pi n by 60. Okay.
Thank you, sir.
Okay. So now let us go to the next one. So here let us read out the problem. The turning moment diagram for a petrol engine is drawn to a vertical scale of 1 mm is equal to 500 Newton meter and a horizontal scale of 1 mm is equal to 3 degree. The turning moment diagram repeats itself after every half revolution of the crankshaft. The areas above and below the mean torque line are 260, minus 580, 80, minus 380, 870 and minus 250. Now the rotating parts have a mass of 55 kg and a radius of gyration of 2.1 meter. If the engine speed is 1600 rpm, determine the coefficient of fluctuation of speed, that is k. So but before going to solve this problem, you have to draw this diagram of turning moment versus crank angle. Right, so if you consider a mean torque, then you are provided some data, right? Let us see. I'm drawing this. So now let us say this as point A, then B, then C, then D, E, F and G. So if I call this turning moment at point A, if I make a table, right, like let us make a table for this, right? So if I say points A, B, C, D, E, F and G, right, that is not a good idea, right? 1 second. If I can one second. It will be better, right? So I'm writing again. So now let me write this A, B, C, D, E, F and G. Now what is given in your problem statement is, if I assume energy at or turning moment at point A as E, then here the areas above and below are given, right? So areas above is given as 260. So here in your turning moment diagram, what is going to happen is, this area is 260, this area is 580, right? 580. I guess this is not that clear. This way, this area is 580, this area is 80, this is 380, this is 870, and this is 250, right? So areas above must be added and below must be subtracted. So at point B it is E plus 260, right? So if you keep on going to point G, then what you have to do is, for C it is E plus 260 minus 580, right? So minus 580, let me correct or more, right? So E plus 260 minus 580. So this way if you keep on going, right, then actually here it is, if you give simplification to plus 260 minus this 580, then it is minus 320. So at point D it is E minus 320 plus 80. So if you keep on going to final point, then you will find that at point G it is again the same, right? So let us see here. Right, so here actually this is E minus 320, this is E minus 240, this is E, here it is minus, minus, sorry,
620.
this is minus, yes, sorry, E minus 620,
620 E plus 250
E plus 250, and again you will have E.
E only.
Right? So this is how you can write the energy at different points. So if you go for this maximum energy, then it is this one, right? This is maximum, yes or no?
Yes, sir.
Right, so
Yes,
this
sir.
is maximum, and minimum is this one, right? E minus 620, correct?
Yes, sir.
Yes sir.
So now if you go for your maximum fluctuation of energy, then it is E plus 260 minus E minus 620, right? Here whatever this energy is there, you have to multiply this with your scale, right? Horizontal scale and vertical scale. So here when you give simplification, it will come around 880. Horizontal scale is crank angle, so it is 3 degree. You have to convert it into radians. So 3 degree into pi by 180.
Pi by 180.
Yes, and into
answer
500.
is 26.1667.
Sorry, into 500,
Answer, sir,
right? Vertical scale.
हाँ
So answer is
26.1 सर 880 बाकी है, एक मिनट सर.
So tell
सर
me what you are-
23026.69.
Actually, it should be coming around 2303
0
Newton
26.
meter,
हाँ
something like
Newton
this,
meter.
right?
Yes sir.
So once you
Yes,
do
sir.
like this, then we are having that E is equal to I omega square k, right? So from that, k is equal to what? E upon I omega square. Yes.
Yes, sir. सर ओमेगा 2 pi nt by 60 से करना है.
Yes, 2 pi n by 60.
की वैल्यू
So now this E is 23038 upon
0.55
I is this m into radius of gyration square, mk square into omega is 2 pi n, that is 1600 by 60 square, right? So tell me your answer.
0.0033 सर.
हाँ 3 के बाद कुछ होगा, so it is almost coming around this 0.0034.
सर 338 आ रहा है, ठीक.
So 0.34%. 0.34%, right?
हाँ सर जी सर.
Okay, okay. Now after this, one more thing is important in case of this flywheel, that is dimensions of this flywheel, right? So if you see this given figure here, this is a flywheel, right, which is having that centrifugal force acting on it as it is mentioned for a particular area of the d theta. If you take that element, then the centrifugal force acting on this can be given as this mass is given as rho into volume. So rho into r d theta, right, that is that length into thickness, right? So this can be the mass, right, rho into r d theta into t, that is mass. And you know centrifugal force is given by mr omega square. So this can be the force acting on that particular element, right? Now if you think about the vertical force acting per unit length, then vertical force acting per unit length can be integrated from 0 to pi with whatever we have written here, this rho r d theta t r omega square sine theta, right? That will be the vertical component. Here it is vertical force, right, per unit length.
सर यहाँ टी थिकनेस है सर.
Yes, t is thickness. So if you
Okay.
integrate it, you will have rho r square omega square t sine theta's integration will be minus cos theta 0 to pi. So you will get something like this 2 rho r square omega square t, right? Now you know
what is the
there is
rho?
hoop stress or circumferential stress is also present in this flywheel, right? So if you consider that circumferential stress,
Sir, what is the unit of rho here?
what is the rho is density.
मतलब मास बटे वॉल्यूम
Yes,
या एरिया.
volume.
सर यहाँ पर तो आर डी थीटा टी तो एरिया हो रहा है ना.
Sorry,
डी आर भी होता तो थोड़ा अच्छा रहता सर.
one second. Unit length we are taking, na? That is why I guess it is like this. Okay.
सर यूनिट लेंथ ऑफ व्हाट?
Unit length of this flywheel. Hello.
ओके सर, मतलब यूनिट लेंथ ऑफ फ्लाई.
Yes, it will have some what we can say, some width or like that, na? That third dimension across the plane of this paper. Are you getting
सर
that?
वो तो टी है ही थिकनेस. ओके हम वो हाँ ओके.
Okay. So now, yes, circumferential stress is also there, right? That is sigma. So if we see the force due to this stress, right, and whatever this force we have calculated because of this centrifugal force, this both must be in equilibrium, right? Or it must be same. So if you equate this two, then this stress into area, again here you need length. So this sigma is sigma into 2t into 1 is equal to whatever we have here calculated, 2 rho r square omega square t. So it will give you that sigma is equal to rho r square omega square. So r omega is nothing but velocity, right? So rho v square, and here again this v is, or v can be calculated by pi d and by 60, where d is diameter of flywheel and n is rpm. And if you write the mass of flywheel, whole flywheel, then it can be rho into pi d into v into t. So it means this density into this circumferential area into cross-sectional area, or you can write that circumference only, that pi d, right, into cross-sectional area, right? So like this you can represent this mass of flywheel. So once you are done with this, then what you can do is you can go for the next numerical, I guess, this one. Now here what is mentioned is the speed variation of an motorcycle engine during the power stroke is limited to 0.8% of the mean speed on either side. The engine develops 40 kilowatt of power at a speed of 130 rpm with 65 explosions per minute. The work done during the power stroke is 1.5 times the work done during the cycle. Now if the hoop stress in the rim of the flywheel is not to exceed 3.5 megapascal and the width is 3 times the thickness, determine the mean diameter and the cross section of the rim. Assume that the energy stored by the flywheel is 1.1 times the energy stored by the rim, and the density of the rim material is 7300 kilogram per meter cube. Now the turning moment diagram during the expansion stroke may be assumed to be triangular in shape. So as the very first thing is, you are going to draw this t theta diagram, and if you remember for this 4 stroke, then it was like this, right? We have seen this. And like this. So here you are having pi, here this 2 pi, here it is 3 pi, and at the end it is 4 pi. So this is crank angle theta, this is torque, right, and this is t mean, right? Here you are having this maximum, right? So if you give this nomenclature, then you can write E P, right? Then sorry, actually it is shifted. Actually here it is yes, sorry, yes, like this. This is theta, this is t, and somewhere here you will have your mean, right, t mean. So it will start with this 0, correct, sorry. So here A, B, C, D, right, and you can have this G and F. So this triangle is the excess energy. It is not that big and like that in my figure, but actually it is 1.5 times that whatever given in our data, right? So 1.5 times the work done during the cycle. So yes, now what we need to do is, as you know, this 1 second, let me shift this also. This is theta. right? Now again let us go with ruled lines. Sorry. Yes. So yes, what we are going to do is this P is equal to 2 pi nt by 60, right? So you are having all the data with you. You are having your mean torque is provided, right? 40 kilowatt, and your RPM is also given 130. So can you calculate this power quickly? Sorry, T mean is not with you, right? It is generally given that 40 kilowatt of power at a speed of 130 RPM. So this 40 kilowatt is in general power, right? Whatever is given.
T mean is 2938.24.
T mean you can calculate from this. This is T mean only. Yes. 2938.2 Newton meter. Okay. Now if you are having this T mean, now energy per cycle, here energy per cycle can be calculated with this T mean into theta of the cycle. What is cycle theta? That is 4 pi angle, right? So 2938.2 into 4 pi, that will be the energy per cycle. So what is that? What is that? 36923 Newton meter. Correct. Now once you have this, then energy during expansion. Energy during, sorry?
So can you kindly go to the previous slide for me?
Yes, energy during expansion is 1.5 times this one. This one. Okay. Okay. So here energy during expansion is 1.5 times this. So what is that?
55384.6
or 55385, let us say, almost Newton meter, right? Now see, T max into theta will be now your this maximum fluctuation, right? So T max into theta, that is pi by 2, will be now equal to this energy what you have calculated, right? So it will give you T max. So if you simplify it, what you are getting as T max? Hello? What you are getting is this one. 35259, I guess. 35259 Newton meter. Yes? Sorry?
Sir, the last line you have written, sir, how it can be?
See, whatever this energy during expansion is there, right? That is whatever that angle turn during that time into that particular torque, right? Because energy is T into theta, right? So here this maximum energy which we are getting during this expansion, it is this whatever T max into that angle turn. That angle turned is pi by 2. So that is why we are having that angle turned with us and maximum energy with us. So from that we can have idea that what will be the maximum torque. So that is why we have written this maximum torque from this. Okay.
Okay, sir.
Now once you have this, then you can go for this in triangle ABE. I will go to that slide. CD upon AB is equal to EG upon EF. From similar triangle it will be like this. Now let us see in that figure where is that ABE. That ABE is here actually. This point is E point, right? E. So this is your triangle ABE, right? In this triangle you are having this similar triangle, right? So CD upon AB is EG upon EF. That is what I have mentioned here, right? CD upon AB is equal to EG upon EF. So once you write like this, then your EG and EF are with you, right? So you can find this CD actually. This CD you can calculate, right? CD, because AB is with you, that is pi. You are having this maximum torque, you are having this mean torque, so all the data is with you. So what you can do is you can calculate this CD. So CD is equal to, AB is nothing but pi, right? And EG is this 35259 minus 2938.2 upon 35259, right? So when you give simplification to this, you can find this CD. Can you tell me what is this? What is this CD? Hello?
Solving.
Yeah.
Sir, 2.8.
2.88 radian it is coming.
Yes, sir.
2.88 radian, right? Now once you have that CD, right, so that E can be now calculated as that area of triangle, right? That is 1/2 CD into EG. So now you are having all the data with you. EG you are having, CD you have calculated. So if you calculate this 1/2 into CD into EG, then you will have that fluctuation of energy. So what is that?
Area of the triangle.
Yes. So anyone got the answer?
1452.3.
So it is around 5646542. Is it? Hello?
Yes, sir.
Yes, sir.
Okay. So now once you know E, then what else is required? You have to calculate this what we can say velocity also, because ultimately you are asked to calculate the K. So this E will be helpful while you are calculating K, right? So once you are done with this, you first go for finding the velocity from the equation which we have derived in the earlier slide, that sigma is equal to rho v square. Sigma is provided, right? If you see the problem statement, then sigma is provided. Here the hoop stress 3.5 megapascal. So here 3.5 megapascal means 3.5 into 10 raised to 6 Newton per mm square is equal to, rho is provided. What is rho? rho is 7300, right? So here rho is 7000, or 1 second.
$7,300.
7300, that is for rim material. One second. So yes, you can calculate this and into V square, right? So now what is V?
$21.89.
21.89
6.
right, meter per second, per second actually, right? So once you have calculated this V, then V can be helpful in finding the diameter, because V is equal to pi dn by 60. N is 130 rpm, right? So can you calculate and tell me diameter? It is in meter per second.
3.21 meter.
So what is diameter?
3.21.
Calculating, sir.
Okay.
$3.219.
3.219.
3.216 meters.
Okay, whatever, right? Now once you are having this, then energy stored in rim, actually whatever we have calculated, this E is for this what we can say, overall flywheel. Now if you talk about the rim, because we are about to calculate the rim dimensions, so this E is for whole flywheel. If you talk about the rim only, then you have to divide this by 1.1, because it is given in your problem statement. So energy stored in your rim, in the rim, is given by whatever you have got, that 46542 divided by 1.1. So it will give you 42311. So for calculating this rim dimension, you have to consider this E, right? So once you consider this E, your K is this 42311 upon I omega square. I is mk square. Here dimension, diameter is given, I guess. So this is mk square. Radius of gyration is 3.285 by 2, and again 2 pi n by 60, that is 2 pi into 130 by 60 square, right? So if you give simplification, you will get your answer. So actually K is given to you, sorry, K is given 0.8 on both sides, so 0.016 is your K. What you have to calculate is, you have to calculate this M. So calculate M and tell me what you are getting as your answer. Hello.
Yes, yes, sir.
So anyone got the answer?
1.89 into 10 to the power of minus 4.
Sorry.
1.89 into 10 to the power of
No,
minus
no,
4.
no, no, no.
सर 5294.4.
5 to 8 9. It is coming around 5 to 8 9 kg, right? Almost. Okay. Okay. So once you are done with this,
Yes, yes.
then you have to calculate the
So
dimensions.
here 1.11 is what factor?
Sorry.
1.11. Why you divided 46,542 by 1.11?
Because
1.1.
it is mentioned in your problem statement that energy, total energy is 1.1 times the energy stored in REAM. That is why I have divided whatever energy we have calculated by 1.1, because we are
Okay, sir.
calculating REAM dimensions. Okay.
And sir, another question in flywheel, you write circumferential stress sigma into 2t into 1.
Yes.
So 1 is what?
One is that length.
Okay, sir, length. Okay, okay.
Here,
Okay, sir.
here this in order to calculate the dimension, we have seen this mass is equal to rho into pi d into b into t, right? So pi d is circumference, b into t is cross sectional area, rho is density, right? So you are having everything with you, right? What you have to do is you have to calculate this width and thickness both, right? Here you are actually given any data, or you can assume by yourself, I guess. Width is 3 times the thickness, right? It is mentioned here. Width is 3 times the thickness, right? So here, if you write all the data with you, 7300 into pi into d is given as 3.285 into 3t, because width is 3 times thickness, into t is equal to 5289. So you can solve it for t. Can you tell me what is t?
.4 mm.
23.4 mm. No.
So 0.154.
0.153, yes. So it is around 0.153 meter. So this is equal to that 153 mm. So once you have t, you can calculate b, right? Because it is 3t. So that is nothing but 459 mm. Okay. So this is how you can calculate the dimensions of flywheel, right? After that, you are having application of this flywheel in punching machine also, as you can see, or punching press also, as you can see here. Here this stroke is used to punch, right, the plate. So whenever this particular distance is going to be traveled, during that most of the power is required, right? Excess power is required when you are going to cut the material in your punching press, right? Otherwise that much power is not required. So here also you are having the requirement of flywheel, right? Similarly in riveting operation also you require this, right? So let us go for another numerical for this riveting. So here a riveting machine is driven by a motor of 3 kW. The actual time to complete one riveting operation is 1.5 seconds, and it absorbs 12 kilonewton meter of energy. Now the moving parts, including the flywheel, are equivalent to 220 kg at 0.5 meter radius. Now determine the speed of the flywheel immediately after riveting if it is 360 rpm before riveting. Now also find the number of rivets closed per minute. So now what we are going to do is, first you are provided with the data of what we can say here the speed of the flywheel immediately after reverting, if it is 360 rpm before reverting, means omega 1 is provided as 360 rpm, right? So if you have not omega 1, it is actually n1, you can convert it to omega 1 by 2 pi n1 by 60, sorry, right? So if you convert it, it will be around 37.7 radian per second, right? Now what else you are provided? You are provided this 3 kilowatt of power, then you are provided that mass of 220 kg, then radius of gyration small k is again provided as 0.5 meter, right? And here that energy required per reverting, energy required, right, per reverting is 12,000 Newton meter, right? So energy supplied per second is also provided 3 kilowatt, right? Energy supplied per second is also provided as 3000 Newton meter. Now energy supplied in 1.5 second, because that is the operation, right? Energy supplied in 1.5 second is equal to this 3000 into 1.5 is equal to 4500 Newton meter, right? Now see energy supplied in this whatever this 1.5 second is 4500. Now energy supplied by the flywheel, that you can get idea about that from the data of this 12,000 Newton meter, because energy required for reverting is 12,000 Newton meter and whatever energy is provided is 4,500 only. So energy provided by flywheel, right? Energy provided or supplied by the flywheel is equal to 12,000 minus 4,500. So 12,000 minus 4,500 is nothing but 7,500 Newton meter, right? So once you have this data 7,500 is the energy supplied by flywheel, then what you can do is you can go for that our standard equation of E is equal to 1/2 I omega 1 square minus omega 2 square. Here I is equal to 1/2 m small k square omega. This is basic equation. We are not going for that I capital K omega square, in which omega is mean speed and K is coefficient of fluctuation of speed. We are going for that our basic equation. E is equal to 1/2 I omega 1 square minus 1/2 I omega 2 square. So from this basic equation you can calculate omega 2, because you are having E with you, small e. Omega 1 you have calculated, m and k both are provided, so only thing is omega 2. So you can calculate this omega 2. So can you calculate and tell me omega 2?
33.9 radian per second, that is 323.7.
Just 33.89 around this radian per second. That is omega 2. So from omega 2 you can have n2, right?
323.7.
n2 is around 323.6 rpm, correct? Right now whatever energy is supplied per minute, that can be calculated. Energy supplied per minute can be whatever supplied per second multiplied by 60, right? So that is your energy supplied per minute. Right now, once you have that energy supplied per minute with you, then you can calculate the number of rivets closed per minute. How can you calculate that? Number of rivets closed per minute is given by this energy supplied per minute divided by whatever energy is required for one riveting operation, that is we have seen earlier 12,000. So whatever energy is provided per minute is divided by the total energy required for one riveting operation will give you how many rivets can be closed in 1 minute. That is 15. Okay, so clear this one?
सर एक चीज पूछे सर, अगर उसको प्रैक्टिकली सोचे कि
हेलो,
यस सर,
हाँ यस,
तो अगर प्रैक्टिकली सोचे तो क्या 15 रिवर्ट हो पाएंगे वैसे?
yes. So whatever is means mentioned, it is generally this can be this can be practically done on your riveting machine. So that is why we have calculated this.
Okay sir.
Okay, next is punching press. So a punching machine carries out 6 holes per minute. Each hole of 40 mm diameter and 35 mm thickness requires 8 Newton meter of energy per mm square of the sheared area. Now the punch has a stroke of 95 mm. Find the power of the motor required if the mean speed of the flywheel is 20 meter per second. If total fluctuation of speed is not to exceed 3% of the mean speed, determine the mass of the flywheel. So here what you have to do is, here the data provided is the diameter is given as 40 mm, then K is given as 0.03, then T is given as 35 mm, and stroke is given as 25 mm. Right, so this is how you are having some of the data provided, right? So, sorry, 95 mm is the stroke. Here it is given, right? Stroke of 95 mm. Right, then N is this, what we can say, V is given as 20 meter per second. Right, now what is given is 6 holes per minute is mentioned, right? 6 holes per minute, so it means 1 hole per 10 seconds, right? So if you go for finding energy per hole, or you can say energy per 10 seconds, then it will be equal to whatever area of the hole into energy required per mm square. Energy required per mm square is given in the problem statement, and area of hole can be directly given from pi dt. Energy required per mm square is 35. So D and T are also given. So sorry, here it is 8, not 35. 8 Newton meter of energy per mm square. Sorry. 35 mm is the thickness. This is 8 Newton meter is provided here. 8 Newton meter of energy per mm square of sheared area, and the area being sheared is given as pi into diameter 40 into thickness 35 to 8, which will give you, can you answer this?
Sir, energy required is
3518.58.
35186 it is coming almost. 35186 Newton meter. So So this is per 10 second, right? So if energy per second you calculate, energy per second will be 3518.6, right? So this is how you are having this much energy per second. Now what you have to check is what will be the time for your operation, right? Because see, 190 mm is the total distance, right? You are having 95 mm of stroke, so that is 190 mm of total distance which is traveled in 10 seconds. So 35 mm is the length which you are shearing. So how much time will require for this 35 mm? So time required for this 35 mm is this 10 into 35 by 190. So that is equal to 1.842 second, right? Now energy supplied in this time 1.842 second is equal to what? We have find per second, that is 3518.6 into 1.842 now. So that will give you, what is the answer? Around 6481 Newton meter it is coming. Are you getting this? Hello?
Yes, sir. Yes.
Right, now once you have this data, which is the energy supplied during that punching time, then your E, right, the fluctuation is this energy per hole which we have already calculated minus this energy supplied in 1.842 second. Are you getting why we have done this? Because we have first seen that what is the particular time for the duration of the travel of punch when it is cutting the plate, right? Because we know what is the energy supplied per second, and we have calculated the time for the operation where the punch is traveling through the thickness of your workpiece. So we have idea that what can be the energy provided during that time, that is 6481, and we also know that what is the energy required per hole. So once we have that idea, then we can have idea that what is the energy provided or supplied by the flywheel, because energy originally provided is 6481 only, while energy required is 35186, as you know, we have already seen earlier. So from this 35186 only, this 6481 is the amount of energy provided. So fluctuation is 28.2705 Newton meter, right? Now once you have this energy with you, then you can equate it to this 2 into k into the energy, that 1/2 mv square, which you can this particular energy is actually equal to this 1/2 mv square, right? Now this k is your coefficient of fluctuation of speed, right? So once you give simplification, you will calculate E, because coefficient of fluctuation is given. So you can calculate your E as 478417, right? And once you get this, then you can equate it to this 1/2 mv square, and where your m is only unknown. So you will find your m as 2392 kg. If we go by the questions asked in GATE, Then this is the first question, as I have mentioned on the screen, that for a certain engine having an average speed of 1200 rpm, a flywheel approximated as a solid disc is required for keeping the fluctuation of speed within 2% about the average speed. The fluctuation of kinetic energy per cycle is found to be 2 kilojoules. Now, what is the least possible mass of flywheel if its diameter is not to exceed 1 meter? Can you try this question by yourself, everyone?
Yes, sir.
Please try this question. I am generating the poll. 1 second. It is 2003. Now I am writing just 2003. 1 second. Can you see the poll? Hello. Please answer this question. Be careful, right, while interpreting this given data. All of you are done? Yes, 51 kg is the correct answer, because see what you have to do is omega can be calculated from this mean speed or mean rpm given, right? That will be around 125.66 radian per second, right? Then this delta E or E, as we have seen, that I omega square k. Now here this E is equal to I is actually mr square by 2, right? Moment of inertia of this flywheel as it is solid is given by this mr square by 2 and into omega square into k. K is mentioned here as keeping the fluctuation of speed within 2% above the average speed. So here it is not that if average speed is there, right, then it is not mentioned that above the maximum side it is 2% and above the towards the minimum side it is 2%. It is not mentioned like this. It is mentioned that it is within 2% both side, right, whatever, maximum to minimum. So that is why here we are not going for doubling the given percentage of this speed, right? So for here for the data given here, the k will be 2% only, so that is 0.02, right? So that is 0.02. so when you put all the data here, what you are going to get is this m is equal to 51 kg, right? Because mass is given to you, right? Sorry, because this all other data except mass is given to you. You have to calculate this mass, right? So this E is given 2 kilojoules, then this omega you have calculated, K you know that 0.02, radius is known from the diameter given, right? So as you are having all the data with you, you can calculate that mass is 51 kilograms, right? Because E is nothing but this 2000 joules, R is this 1/2 because diameter is provided, omega you have calculated, K you have written, so mass you will be able to calculate. So everyone got this one? Yes or no?
Yes, sir. Yes, sir.
Okay. Now if we go for the next one, this. So here, if CF is the coefficient of speed fluctuation of a flywheel, then the ratio of omega max minus omega mean. Can you try and write your answer in the chat box only, whatever A, B, C, D you are getting? Can everyone try? Hello? Hello? Can you try?
Yes, sir. Yes. Yes, sir.
Please try and type your answer in chat box.
Sir, please show the
Yes, you can see.
It is coming DD.
Yes, correct. T is the correct
Yeah.
answer, because see, whatever CF we are having, right? CF is the what we can say coefficient of speed fluctuation. We have defined it as omega max minus omega mean divided by omega mean, right? Where omega mean is omega max plus omega mean by 2. This is what omega mean, right? So if you put omega mean in the above equation, then CF is equal to omega max minus omega mean by omega max plus omega mean by 2. So now if you further simplify, then it will be CF by 2 is equal to omega max minus omega mean divided by omega max plus omega mean, right? So this 2 plus CF and 2 minus CF, when you do the same on the other side, it will give you omega max by omega mean. Actually 2 into omega max by 2 into omega mean, it will give you 2 will be cancelled out, correct? Yes or no?
Yes, sir.
Okay.
Yes, sir. Yes, sir.
Okay, next is this one. The speed of an engine varies from 210 radian per second to 190 radian per second during a cycle. The change in kinetic energy is found to be 400 Newton meter, the inertia of the flywheel. You can calculate this, right? Because E is equal to 1/2 I omega 1 square minus 1/2 I omega 2 square. Very simple. Quickly calculate and tell me You can directly do this, right?
Can you kindly go to the previous slide for a minute?
This one.
BA.
Okay, thank you.
Mm-hmm.
सर कितने बजे तक क्लासेज हैं ये वाली? ओ कितने बजे तक का सेशन है सर?
Yeah, actually 10 to 15 minutes more, I guess, because we
Yeah,
are having
option
some
is
more
point
questions, right? 15 to 20 minutes more. Okay,
Sir, option A, point 1.
point 1. Okay, everyone is getting the same. Hello.
Yes, sir. Yes, sir.
So I guess it is very straightforward, right? This 400 into 2 is equal to I. Omega 1 minus omega 2 is what? 20. Omega 1 plus omega 2 is what? 400. Right? So this way you can get I is equal to 0.1. Clear? Okay. The next one. Here a circular solid disc of uniform thickness 20 mm, radius 200 mm and mass 20 kg is used as flywheel. If it is rotated, it rotates at 600 rpm. The kinetic energy of the flywheel in joules is. Can you try it by yourself? It is also very simple. All the data is given to you. Kinetic energy is nothing but 1/2 I omega square. Can you try? I is mr square, moment of inertia.
Yes, sir.
So you can calculate. Omega is 2 pi n by 60. So everything is with you. Can you calculate?
Yes.
And type in your answer, or you can unmute and tell your answer. Yes.
Sir, B.
790 is the correct answer. Yes. So when you put all this data, you will find this one. Mass is given 20 kg, R is given, right? And N is also given. So you can have your answer as 790. Okay. Let us go to the next one. A flywheel connected to a punching machine has to supply energy of 400 Newton meter while running at a mean angular speed of 20 radian per second if the total fluctuation of speed is not to exceed plus or minus 2%. The mass moment of inertia of the flywheel is. It is also simple, I guess. You can do it, right? Nothing. This K is 4% here actually because it is plus or minus 2%. So this energy is given, then you are having this what we can say, this angular speed or mean angular speed. So in your E is equal to I omega square K, everything is given and you have to calculate I. So it is easy. Can you try?
25.
So all of you are getting the same? Everyone is getting the same? Hello.
Yes, sir.
Okay.
No, sir.
Huh?
No, sir.
Not getting this answer?
आ गया सर.
Okay. So you got this one, right, everyone?
Yes, sir.
Okay. So now we can go for the next one. This is 14 set 2. Maximum fluctuation of kinetic energy in an engine has been calculated to be 2600 joule. Assuming that the engine runs at an average speed of 200 rpm, the polar mass moment of inertia of a flywheel to keep the speed fluctuation within plus or minus 0.5% of the average speed. Here also plus or minus 0.5% means 1% only, right? So can you try this question? Hello,
Yes, sir. Yes, sir.
please try this question.
Sir, 592.
592.73 something, yes, because here also E is equal to I omega square K, as we have discussed. 2600 is equal to I. Omega square means 2 pi 200 by 60 square, and K is 0.01, right? So I will be almost around 592.73, right, kg. Next one, here torque and angular speed data over one cycle for a shaft carrying a flywheel are shown in the figures. The moment of inertia of the flywheel is here. Actually you have to take all the data from the figures which are given to you. So can you try this? Hello.
Yes, sir. Yes, sir.
सर पोलर मोमेंट ऑफ इनर्शिया तो अलग होता है ना. पाई बाय आर स्क्वायर होता है और एक पाई बाय 2 आर स्क्वायर होता है.
Actually for now it is considered this only. I will check still, right, and I will let you know. Okay.
ओके सर.
Okay, so for now calculate this one.
Sir, 31.41.
How?
Sir, from here we have a. So, wait, sir, wait. The moment of inertia I am getting is 31.41, and first I have find the we have given a time period 2 pi from t theta diagram, and then I find the work done from there, and in the second angular speed and theta diagram I have got this omega max that is 20 and omega mean 10.
How have you calculated? How have you calculated the delta E?
Sir, above the mean is the maximum fluctuation of the energy, and first I have calculated the mean, so which comes to be 0. That is theta diagram is our mean line. Area above the mean line is maximum fluctuation of the energy.
Okay.
From there I have calculated 1500 pi, that is the maximum fluctuation of energy, and after that I have applied half I omega max square minus mean square, and we have omega max as a 20 and omega mean as a 10. Then after that, I have got this 31.41.
Okay, so everyone is getting the same? Hello? Everyone is getting the same?
सर प्लीज थोड़ा टाइम दे दीजिए.
Mm-hmm. Your omega max and omega mean is 20 and 10 respectively. So you can calculate your omega mean and k from this data. And one more thing you have to calculate is that the fluctuation. Okay, so shall we move to the next one?
सर फ्लक्चुएशन नहीं मिल पाया.
See, as he has mentioned, you will get the area above the mean line, that is 1500 pi, that you have to equate to I omega square k. So you will get 31.26 around answer. Right?
ओके सर.
Okay, so let us go to the next one. This one here. Here the torque is provided in this equation, means it is provided in this relation with theta, right? The torque exerted on the crankshaft of a two-stroke engine can be described as T is equal to 10,000 plus 1000 sine 2 theta minus 1200 cos 2 theta, where theta is the crank angle as measured from inner dead center position. Assuming resisting torque to be constant, the power in kilowatt developed by the engine at 100 rpm. So here what you have to do is you have to integrate this, right? Whatever this torque is given, right? So you have to first integrate this in order to get this T mean. So 10,000 plus 1000 sine 2 theta minus 1200 cos 2 theta, right? 1 upon 2 pi, 0 to 2 pi. So and d theta, right? So when you integrate it, you will find this T mean. When you put all these values and integrate it, it will come around 10,000 actually, right? So once you get this, then what you have to do is you have to calculate that power. So once you have the T mean, then power is nothing but T mean into that theta, right? Sorry, T omega. Power is nothing but T omega, right? 2 pi nt by 60. So here n is given as 100 rpm. So once you have this T mean, then you can calculate power. It will come around 104.719, right? You can verify this, right, after integrating this and whether you are getting this or not. Okay, so you can check it, right, once you integrate it. Is it okay?
Yes sir.
Yes, sir. I am getting same.
Okay.
104.
Okay. So the next question is from GATE 2022, Code 2020, sorry, GATE 2020 session 1. A flywheel is attached to an engine to keep its rotational speed between 100 radian per second and 110 radian per second. If the energy fluctuation in the flywheel between these two speeds is 1.05 kilojoule, then the moment of inertia of the flywheel is. It is again simple question, I guess. Directly delta E is given or E is given, right? Energy fluctuation is given directly 1.05 kilojoule, and both the speeds is given, so it is again directly 1 half I omega 1 square minus 2 square will give you answer, isn't it?
Yes.
बना रहा है
1 आएगा, yes, 1 kg meter square.